So we should all know that Pythag is going to be c squared is equal to a squared plus b squared in a right triangle where c squared, or c, is equal to the hypotenuse every single time. At the same rate, if I want to isolate one of the other side lengths, then a squared would equal c squared minus b squared, or b squared would equal c squared minus a squared. So if I am solving for these, well, in this case, for the first one, I'm solving my hypotenuse, or I'm solving for my c value. So x squared is going to equal 2.5 squared plus 3.7 squared. 2.5 squared plus 3.7 squared is going to equal 19.94. And then to solve for x, I just square root both sides, which means that x is going to equal 4.5 centimeters. In the second case, if I'm trying to solve the third side length, well, here I have side length AB. I'm going to call this, for our purposes, y. This is obviously not the hypotenuse, which means that y squared is going to equal the hypotenuse squared minus the other side length squared. Or y squared is going to equal 484. And then I'm going to square root both sides. Y is going to equal 22 millimeters. If I'm using the trig ratios to calculate a side length, at the beginning we reviewed the procedure for calculating the third side if the other two sides are given, but it's also possible to use a side length as well as an angle or a ratio in order to solve the missing side. So in this case, the first thing that we're going to do is we're going to isolate, well, here is the angle that I'm using. There's my acute angle. Beyond that, I know that there is the hypotenuse is the information that I have, and the opposite is what I'm trying to solve for. If I have an angle, that means that I have sine, tan, and cos, because I can just put in sine of the angle, tan of the angle, or cos of the angle. So all I'm looking for is which ratio is going to include the opposite and hypotenuse. The only one that uses opposite and hypotenuse is my sine ratio. So I'm going to say that sine of the angle of 52 degrees is going to equal angle x divided by my hypotenuse, 14.2. In order to get the 14.2 out of the bottom, I'm going to multiply both sides by 14.2 and say that 14.2 times sine of 52 is going to equal angle x. And I can just put that into my calculator, making sure once again that we have it in our degree mode, not in our radians mode, just in case. So to one decimal place, well, if I say 14.2 multiplied by sine of x, that's going to give me 11.2 centimeters. If I put this into practice, a ladder 4.5 meters long reaches the top of a wall. The angle between the ladder and the ground is 65 degrees. Make a rough sketch to determine the distance between the bottom of the ladder and the bottom of the wall to the nearest tenth of a meter. Well, I'm going to draw a picture, and I'm going to state that this is my ladder. I'm going to state that this vertical thing here is my wall. And this last side is going to be the ground. We know that the ladder is 4.5 meters long. We know the angle between the ladder and the ground is going to be 65 degrees. And if we're trying to solve for the length between the bottom of the ladder and the bottom of the wall, we're trying to solve the length along the ground. Given the information that I have, in this case, I can state that I know my hypotenuse is 4.5, and I'm trying to solve for my adjacent based on the angle that I know. The only one that has adjacent and hypotenuse is going to be cosine. So I'm going to state in this case that cos of 65 degrees is going to equal, well, let's call this distance along the ground g divided by my hypotenuse 4.5, which means that g is going to equal 4.5 multiplied by cos of 65. It's going to be approximately 1.90. So the distance is 1.9 meters to the nearest tenth. For example 3, it wants us to take the information from our last case and determine the height of the wall, so the last missing part, because we know that along the ground is going to be 1.9 meters. We can either solve for the last side, or the height of the wall, using trig ratios, or we can do it using the Pythag. So let's start by doing it using trig ratios. Well, if I'm doing it using trig ratios, then I know my hypotenuse, and in this case I'm trying to solve my opposite. So I'm going to go back to sine of 65 is going to equal the length of the wall divided by the hypotenuse of 4.5. The wall is going to equal 4.5 times sine of 65, or the wall going all the way up to the top is going to be 4.1 meters. If I did the same thing using Pythag, then I would use the 2 that I already know or have solved for. I'm not solving for the hypotenuse, so the length of the wall squared is going to equal the hypotenuse, or the length of the ladder, squared minus the length along the ground squared. This is going to give me 16.63, and then I'm going to take the square root of both sides, and the wall is still going to be 4.1 meters when rounded to the nearest tenth. In all the previous work, the side which had to be determined was the numerator. We can also get this from when we're solving for the denominator. So, if I have this angle, I know the adjacent is 7.9, and I'm trying to solve for my hypotenuse of A. Well, the only one with adjacent hypotenuse is going to be cos. Cos of 64 is going to equal this, which means to get A out of the denominator, I multiply both sides by A and say A times cos of 64 is equal to 7.9, and then I'm going to divide both sides by cos of 64 in order to get A by itself. So A is equal to 7.9 divided by cos of 64, or to the nearest hundredth, 18.0. if I'm putting that into practice, determine to 1 decimal place the length of the hypotenuse in triangle PQR, where PQR, or the angle at Q, is going to be 90, the angle at R is going to be 28, and the length from P to Q is going to be 15.6 millimeters. So the first thing I have to do is I have to draw what this is going to look like. Well, I know that my 90 degrees is going to occur at Q. It doesn't matter where I put the other two, so I can say that one's going to be P and one is going to be R. Those are both going to be acute angles. And I'm going to say that at R, it is 28 degrees, and the length from P going to Q is going to be 15.6 millimeters, and I'm trying to solve for my hypotenuse. So in this case, if I know my adjacent, I know my opposite, and I'm trying to solve my hypotenuse, I'm going to have to use my sine ratio. So sine of 28 is going to equal 15.6 divided by my hypotenuse. My hypotenuse times sine of 28 is going to equal 15.6, or my hypotenuse is going to equal 15.6 divided by sine of 28. And in this case, my hypotenuse is going to equal 33.2 millimeters if I'm going to 1 decimal place. For the last example, use trigonometric ratios to determine the lengths of AB and AC in the given triangle. Well, here's my angle. One is going to be my hypotenuse, and the other one is going to be my opposite. And what I know is my adjacent. So first, if I am going for the side length of AB, then I'm solving for my opposite. I know my adjacent, which means I need to use my tan ratio. So I'm going to say that in this case, tan of 71 is equal to the side length of AB divided by 147. Side length AB is going to equal 147 multiplied by tan of 71, which means that AB is going to equal, to the nearest meter, 427 meters. For AC, AC is my hypotenuse, and I know my adjacent, which means that in this case, I'm going to use my cos ratio. Cos of 71 is equal to my adjacent divided by my hypotenuse of AC. AC times cos of 71 is equal to 147, or AC is going to equal 147 divided by cos of 71. And my hypotenuse is going to equal 452 meters.